Hello everyone. So in this particular video, we are going to discuss question number 4 of GATE DI24 exam. Okay. Now, in this question, we need to find out the sum of the following infinite series. So this particular infinite series is given to us and we need to find out the summation of this. So how to solve this type of question? Okay. But before that, you should know the concept of geometric series. Okay. Do you know what is geometric series is? Now what is geometric sequence first? The sequence of a number in a such a way that the next number we will get by multiplication with the previous number. It means that the ratio between the two successive number is same. For example, let's take geometric series, right? So this is basically summation of infinite numbers in a such a way that, for example, my first term is a, my second term is ar, my third term is ar square. So when I take the ratio of this particular number with this previous number, that will always be a constant. For example, ar square divided by ar, that will be r. Similarly, ar divided by a, that is also r. Here also my next term will be ar cube, right? Because if I just multiply with the common factor, so r is basically a common factor. If I multiply common factor with the current term, I will get the next term, that is basically ar to the power 4. So in this way I can get till ar to the power n, like this. Okay, so this is basically a geometric series. Here we have n numbers. Okay, in the question we are given infinite series. So how to find out the summation of this particular series first? But before that, you should know few things. My first term, the first term of this particular series is what? A. So here first term is a, and I have a common factor. What is common factor? Common factor is r, such that if I take the ratio between two successive terms, for example ar cube divided by ar square, that will be always a constant between any two successive numbers. So that is also r, right? Now the summation of this particular terms, now the summation of this particular series, that is geometric series, is given by s and a divided by 1 minus r into bracket 1 minus r to the power n. Okay, so this is the summation of nth numbers by or nth term from this particular geometric series. Okay, now this is for the fixed number of terms. But what if in the case of infinite series I don't have any fixed number of term here? In that case, so sum of infinite geometric sequence is what? Sn equals to, not S infinity equals to a divided by 1 minus r. That's it, right? So this will give me sum of infinite geometric sequence, like for this particular example. So in this case, we need to use this particular formula, a divided by 1 minus r. Okay, and what is a? A is the first term and r is the common factor. Now we need to identify how I can apply this particular concept of geometric series to this particular question. Okay, if you want more clarity on geometric series, on harmonic series, please comment below. I can record one tutorial based on this. Okay, because you can expect one question from this particular topic also next year. Okay, so this is basically aptitude part. You can just refer to any YouTube video for this particular topic. That will be more than enough. Or you can tell me, I can also record for this particular topic. Okay, now let's try to think how we can apply this particular concept here. So can I write this series as like this? So 2 will be as it is, 2 plus, then can I write 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16, right? Plus till like that, plus again remaining term is what? 1 by 3 plus 1 by 9 plus 1 by 27 plus like this. So I can write this particular series like this. Now can I apply this particular concept here, geometric series? Yes. If you observe here 1 by 2 plus 1 by 4 plus 1 by 8, if you consider any two successive term here, the ratio is what? So if I take 1 by 8 divided by 1 by 4, So what I will get? 1 by 2. So here R is basically 1 by 2 for this particular series. I am considering this series 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus till so on. So my first number, that is A, is basically what? First term is 1 by 2. What about common factor R? Common factor R is what? Take any two successive term and just take the ratio. So 1 by 16 divided by 1 by 8. So that will be what? 1 by 2. So A is 1 by 2, R is 1 by 2. The summation of this particular series is what? This particular formula. A is 1 by 2, 1 minus 1 by 2. So that is basically zero point 0.5, and 1 by 2 divided by 1 by 2 is what? Is 1 only, right? So 1 by 2 divided by 1 by 2 is 1. So I got this particular thing is 1. Now what about this series? 1 by 3 plus 1 by 9 plus 1 by 27. Can I apply this particular concept here? Is this a geometric series? Here my first term is 1 by 3, and do we have a common factor? If I take a ratio of first and second term, what I will get? 1 by 9 divided by 1 by 3 is what? 1 by 3. Similarly, 1 by 27 divided by 1 by 9 is what? 1 by 3. Right? So here A is 1 by 3 and R is also 1 by 3. So what will be the summation of this particular thing? So 1 by 3, 1 minus 1 by 3. So it will be 1 by 3 divided by 1 minus 1 by 3 is 2 by 3. So 1 by 3 get cancelled, that is 1 by 2. Right? Now I know the summation of this particular thing is 1. I know the summation of this particular thing is what? 0.5, and I have this 2. So 2 plus 1 plus 0.5 is basically 3.5. So 3.5 is what? This. So option B is correct here. Okay. So this question is based on geometric series. If you know this particular concept, then only you can solve this type of question. Okay. So I will suggest you for aptitude part. So please go through this particular topic. Okay. I hope you understand this particular thing, how we have applied the concept of geometric series in this particular question, and how we divide this particular series according to this particular thing. Okay. So this formula you have to remember. If there are fixed terms, then you can use this particular formula. If there are infinite terms, then you can use this particular formula. Okay. I hope you understand this particular question. So that's it from this particular video. Thank you.